Good. Let's proceed with determinants. Right. So in this example 2, the question is find the determinant and numbers of the following matrix. Like I'll do the first two, and then you do the rest. So A is given by 3, 1, 2, 5. Its determinant will be given by 3 times this, which is 15, minus this times this is 2. So its determinant is 13, which is so easy, right? Very easy. Now let's find its inverse. A inverse is equal to 1 over determinant of A multiplying the cofactor matrix. The cofactor matrix here would be 5, 3, minus 1, and then 2. Minus 1 minus 2, sorry. So we have 1 over determinant is 13. Multiplying 5 minus 1 minus 2, 3. And multiply, we have 5 over 13 minus 1 over 13. We have minus 2 over 13 and then 3 over 13. So that's the answer here, and we are right. Right? Sometimes you can also leave it here because sometimes it's so complex. It's a little complex, so you can just leave it like this as a product. And sometimes you can expand and get this. That's it. Let's try B. B is given by 3 minus 2, 7, 4. Its determinant is given by 12 plus 14, right? That's 26. B inverse will be given by 1 over the determinant, which is 26. That's the reciprocal of the determinant. Multiplying the cofactor of B. Looking at B, cofactor will be 3, 4 because we exchange the forward diagonal and then we negate the backward diagonal. So when we negate this, we move from negative 2 to 2. When we negate this, we move to negative 7. Perfect. That's the determinant. We could leave it this way, or we could expand it to 4 divided by 26. That would be 2 over 13. Then the next one will be 1 over 13. Then the next one will be minus 7 over 26. And then finally 3 over 26, which is so simple. That is how we find the inverse of it. Right. So the formula we learned here is so simple. Let me try and write it here, which is most important. The inverse is equal to the reciprocal of the determinant multiplying to dA minus B minus C. Right. This is the reciprocal of A, right, of determinant of the determinant of A, reciprocal of the determinant of A, reciprocal of the determinant of A, and then this right here is the cofactor matrix of A. Right. It's so simple. You just have to know the formula. And then we also learned the formula for determinant is equal to AD minus CB. Right, the forward diagonal minus the backward diagonal, where A is equal to ABCD. So the determinant is given by this times this, right, minus this times this. So these are the formulas we've learned so far. We'll be able to find C, P, Q. We can do the same thing there. Then we compare our answers. Right, so we solve one example of the inverse with the other method. So you always check that your inverse is correct by multiplying the matrix by your inverse and check if your answer gives this, right? So let's see some examples that we solved. In A, how do we check whether this answer is correct? If you want to verify that this answer is correct, we can use this statement that whenever we multiply a matrix by its inverse, we're supposed to get the identity element. Let's see if this is true. So our A was 5 minus 1 minus 2, 3, and our inverse was 5 over 13 and 1 over 13, then negative 2 over 13, then 3 over 13. Now let's try multiplying these. 5 times this, right? We're going to have 5 times 25. That will give us 25 over 13. Plus 1 times 2 over 3, right? 1 times minus 2 over 3, that will be plus 2 over 13. Right, then the next one, 5 times this, we have minus 5 over 13, then 1 times this, we have minus 3 over 13. Next one, this times this, we have minus 10 over 13, then plus, this time is plus, that will be minus 6 over 13, then 2 times this, we have 2 over 13, then this times this, we get plus 9 over 13. Wait, our answers are not like they are supposed to. This is not giving us identity element. So there is a mistake somewhere. Our A was wrong. Like we took cofactor instead of A. The A is 3125. So let's change that here. So our A was wrong. A is 3125. So multiplying these, we get different set of values. Right, so let's start. Right. Let's start again. 3 times 2 over 5. We'll have 15 over 13. Plus this times this, that will give us minus 2 over 13. 3 times this, that's minus 3 over 13. Then 1 times this, that's plus 3 over 13. 2 times this, we have 10 over 13. This times this, that's minus 10 over 13. Then 2 times, it's just like we do any other multiplication. Minus 2, then this times this over 13. Then 5 times this is 15 over 13. Banana. So let's add. When we add, we get 13 over 13 because we have 15 over 13 minus 2 over 13. So we subtract 7 meters. So we get 13 over 13 here. Then let's see here. We have 3 minus 3 plus 3 over 13, which is 0. That'll be 0 over 13. This 10 minus 10 over 13. That's 0 over 13. Then here, when we add them, we have 13 over 13. When we simplify, this becomes 1. This becomes 0. This becomes 0. Once the numerator is 0, we have 0. Any fraction with the numerator being 0 is 0. Then 13 over 13, that's 1. So perfect. That's our identity elements. Identity elements are always like this. Have ones on the leading diagonal and zeros elsewhere. So we are correct. So you can do same for all the other examples. Another example here. Find the value of key for which the following matrix have no inverse. Right. It says that it has no inverse. So that's the key word. When a matrix has no inverse, it implies that its determinant is equal to 0. So we can find the determinant of these and equate to 0. So let's find the determinant of the first one. Q7, 8, 2 is equal to 0. The formula for determinant, just multiply this, the leading diagonal minus the backward diagonal. So leading diagonal product will be 2k minus the backward diagonal will be 7 times 8, which is 63. Right? Which is 56, sorry. 56 is equal to 0. So k becomes equals to 28. And that is very easy. K is 28. It's the same here. It's same here. The determinant is 0. So it's the same approach. You can find the determinant and equate to 0. Right. Solve simultaneous equations using so get there. So it's very simple. It's all very simple. So finally we'll just solve use the increments rule, right? So that will be the last thing in here, right? We'll use the increments rule.